Oh, hi there. Thanks so much for showing up for your math learning, everyone. We're going to do a Delta Math walkthrough where we go through all the different Delta Math topics for this week. All right, let's go. So I'm doing this as a student, so I'm answering the questions just as you will see them. So I need to write the number 4.1 times 10 to the minus 5 in standard form. This will be 0.00041. Okay? 41. Yeah. I need another 0 there. There we go. How did I do that? Okay, I do it this way. I'm going to take that like those digits, 4, 1, and then move the decimal point 5 times to smallify the number. 1, 2, 3, 4, 5. I have to fill in the extra zeros, put the dot there, and then that's my number. Okay, submit it. Oh, let's do another. Okay, write this in standard form. Well, the decimal point's going to move twice, so that's going to be 0.046. Yeah, let's go. Okay, this one, it moves 3 times, but because the exponent is positive, it's bigifying the number, it's growing larger. So this is 1.4 times 1,000, 1.4 times 3 tens, so that's going to be that number. Hooray. Let's go 8.6 times, so that's 8, 2, and then it's going to be that number. 10 to the 5 happens to be 100,000. So 8.2 times 10 to the 5 means we have 8.2. It is equal to 8.2, but we're going to move that 1, 2, 3, 4, 5 times. 1, 2, 3, 4, 5. There we go. A what?
A blue phone over here.
I don't know if there's a blue phone over here.
Teacher informative that we have.
I don't know. I don't see one. Okay. So we're going to say submit. Yeah, there we go. Next problem. So here, 3.9 times 10 to the minus 2. 0.039. Ooh, 9. Yeah, there we go. See, the decimal place has moved twice. And that's it. Next section. Let's go. All right, we've been asked to write this in scientific notation. We're going to pull that decimal point after the 8. I see that I need to move it 4 times. So we're going to be 8.0, so nothing after the 8. Times 10 to the negative 4. Right. Okay, let's go. This one, 100,000. Let's see if it takes it without a 0. That's 10 to the 5. I just see that I need to move the decimal point 5 times to get it right behind the 1. So that's that. It likes it. It is big. Okay, and look at their explanations, right? It's going to be like some positive number. Move the decimal points 5 places to the left. Boom. There we go. All right, next. So this is 5.9. This number is small. So we have to move it, let's see, 1, 2, 3, 4, 5 times. So to the negative 5. And that is all. Okay, let's go. This is 2.8. We only want 1 decimal point to the left. We have to move it twice. So that's that. Let's go. This one is 2.6. We have to move it 5 times, and it's small. This is what we do. Okay, next section. All right, so now it's asked for the quotient of these two numbers. These are calculator questions, so absolutely use a calculator for these. We can get out the virtual keyboard, we can get out a calculator in there, but I'll show you how I would work these myself. We want to express the answer in scientific notation. So I'm going to have 1.843 times 10 to the 7 divided by 4.85 times 10 to the 4. Okay, that's going to be equal to something 10 to the 3 because I would subtract exponents in this case with those bases. And then I'm going to use my calculator. I'm just going to get one out here, but you can use a plastic calculator if you want. 1.843 divided by 4.85. 0.38. So we have 0.38 times 10 to the 3, but that won't do. We need 3.8 times 10 to the 2. See, I borrow one of these 10s to multiply that to put it into scientific notation. 3.8 times 10 to the 2. Hooray. What's the product? Okay, the product means multiply those things. So 6.8 times 9.3, I'll work that out. 6.8, let's just move this over so you can see where I'm getting these numbers, times 9.3. Okay, that's 63.24. So actually I'm going to use 6.324 because that's where I want the decimal place. I'm multiplying by an extra power of 10 by moving the decimal place. So I have 10 to the 11. Where did the number 11 come from, Mr. Jennings? Help us. Okay, I'll help you. All right, 6.8 times 9.3 times 10 to the 4 times 10 to the 6 equals, we were told that 63.24 times, add these exponents because we're multiplying powers of the same base, 10 to the 10. Moving that 1 that way is like dividing by 10, so we better multiply by an extra 10 to balance it, to make it the same. So that would be then 10 to the 11, this number. Okay, so this one, 8.7 times 7, I can do that in my head, but I don't want to. I just want to, I have a calculator out, so it's 60.9 times 10 to the 9, 6.09. 6.09 times 10 to the 9. I added these exponents, the 5 and the 3, but then I have to add one more because it's not 60.9, it's 6.09. So when I move that over, I have to rebigify. Cool. Next problem. All right, let's go. That's a very calculator question. 1.888 times 5.9. I can see there might be ways to do that. I don't want to do that in my head or on paper. Okay, so it's we're gonna have 1.11392, and our power of 10 is gonna be 16 because 9 plus 6 is 15. We add 1 because we have to adjust that decimal place by 1, so 16. Oh, it's so good. Did I write the number down wrong? No. The quotient. It wants the quotient, not the product. I didn't read the question right. So we have to divide. Okay, so let's write it out. Okay, so here we go. 1.888 times 10 to the 9 divided by 5.9 times 10 to the 6 equals, let's do that division on our calculator, 1.888 divided by 5.9 equals 0.32. Of course, that's much more like the answers that it likes to give us. 10 to the 3, because we subtract the exponents in this case when dividing. And then I want to adjust that way, so it's going to be 3.2 times 10 to the 2. Good. Last one. Okay, quotient. So I divide 4.644 divided by 6.45 equals 0.72, so we're going to be 7.2. And we subtract the exponents, so that's 5, but I borrowed 1 to rebigify my number, so that's 4. Next section. So now we're adding and subtracting in scientific notation. All right, so this one here, these ones, you just have to expand them. 10,700,000 minus, well, what is that number? 1.41 times 10 to the 6 is 1,410,000. And that's that number. So we're going to write that number over here. 1,410,000. Really? Really? Okay, we're going to
Did you go?
pause here.
I did one of that first period and I got
Slapping someone.
All right, let's keep going. So I'm going to start speeding up. I'm not going to do every single problem, but here we go. We just want to do this subtraction. So in order to do that, I'm going to borrow here I also need to, and then, so that's like 10, yeah, so that's 9, and then I have to borrow there, that's a 6, that's a 10, and so that's a 2, that's a 9, and I need to give this number in scientific notation. There's a 0 there. It says 9.29 times 10 to the 6. There, so that's how that one would go. Okay, and you just need to do those. Okay, just do that. Let's go back to, so add, subtract, and scientific notation, level 2. Here we go, negative ones. So again, you have to expand these. All right. This one, because they're the same power, though, there is a shortcut available. I'm not going to teach you the shortcut. You can discover it yourself. This is a 0.000055 and 0.000027, and we are subtracting. And so then this is going to borrow here. That's a 4, that's a 15, and so 15 minus 7 is 8, 2. So this is 2.8 times 10 to the minus 5. What? Oh, it's plus. Thought it was subtract. Read the question carefully, Mr. Jennings. All right, so 5 plus 7 is going to end in a 2, and then that's carrying a 1, so we're basically 6 plus 2 is an 8, so that's 8.2 times 10 to the minus 5. It's interesting, it's just flip the digits. Wow. Yay. Okay, so I'm adding, I'm not subtracting, all right? So what we would have here is instead we're just add. So we are 5 plus 7 is 2, carry a 1, 1 plus 5 plus 2 is 8. 82 down there, but after the 0, 0, 0, 0, decimal 0. That's your answer. All right. So now let's go back. We'll do the next type, greater versus times greater. So these ones are good questions. So we have like 2 different cells here, and we capture images under microscope and then use software to measure their diameter. That's really interesting. That's like how some science is done. Okay, so we get to, I like delta math. What can I say? I like it. So, so we measure its diameter, 2 cells are measured, and then we've got them. How many times larger is the diameter of cell M than the diameter of cell N? Okay. We want this in standard notation, rounding to the nearest tenth. So times greater, we have 5.34 times 10 to the minus 3 divided by 9.3. Because this is a times greater question, we want to use division to see how many of that smaller cell would go into the bigger cell. And then this one, I mean, let's just, you can just do all these on a calculator, right? Sure, 5.34 times 10 to the 3 but negative equals that, divided by, put it in brackets, 9.3 times 10 to the, 10 to the 4, but it's negative, and the bracket equals 5.7 times bigger. All right? So it's 5.7. Cool, submit. Yeah. Okay, next problem. How many times larger? So again, we're saying how many times larger is Arkansas than Rhode Island? Okay, how many Rhode Islands fit inside Arkansas? All right, so there's a lot of questions about the United States. This is a U.S. program. Learn about the United States is kind of a big deal in the world. All right, so we're dividing again. So I'm just going to do this the easy way because I know my powers of 10. So it's 1.38 divided by 4 is equal to 0.345. So, but then it's going to be multiplied by 100. So it's 34.5. Oops, 34.5 times bigger. Why? Because there's an extra like 2 powers of 10 in that what looks like the smaller number. It's actually the way bigger number. Arkansas way bigger than Rhode Island. Okay, Venus and Mars. How many times larger? I want a different one. I want one that's how much larger. But anyway, let's see. So if I show example. So here, this is like an example of a how much bigger question. Okay, the approximate areas of Arizona and Indiana. Arizona is a fair bit bigger than Indiana, but not that much. Like it's about like a little bit more than twice, a little bit, about 3 times as big as Indiana there, if I had to do the division. But if we were asked what's the difference, okay, then we're not asked how many times bigger, it's a how much bigger question. So this one you need to recognize that we have to use subtraction there to answer that type of question. And then when we do it, we get 270, and then it's asked for the thing in scientific notation, so you would do it that way. Okay, cool. So that's that type of question. All right, now let's keep going. We have mixed word problems. I'll do a few of these because some of these might be tricky. Okay, so let's go. So a water park has pools and slides and rides that in total make use of this much gallons of water. They want to add a ride that would use this many more gallons of water. We want to now know the total gallons of water made use of in the park. Okay, so in order to do this one, I need to recognize that I want now a new total. Totals come from adding. So I'm going to add a new ride to this park, and I want to know the total new amount of water. So we are now using 690,000 gallons of water, and we're adding a ride that's going to use 83. And so that's going to be a 3 there, a 7 there, and a 7 there when I add this up. So it's going to be 7.73 times 10 to the 5 gallons of water. Okay. The distance from Earth to Mercury is that. How long would it take a rocket traveling at this many kilometers per hour to go from Earth to Mercury? Oh, so this is a speed question, and we want time. So I do distance divided by speed will give me time. Okay. 9.21 times 10 to the 7 divided by 3.93 times, I bet that's like, oh, interesting, times 10 to the 4. Okay, so let's divide those number bits. 9.21 divided by 3.93, 2.34, 35. How accurate do they want it? Round the answer to the nearest whole number of hours. Okay, but then I need to multiply this by 1,000 because we have to subtract the exponents here, so there's still a 10 to the 3, so I'm going to go times 1,000. Oh, shoot, there we go, times 1,000 equals this. Round it to the nearest whole number of hours. 2344, that 0.5 rounds it up. Okay, so 2344. And that's how these do. Okay, you have to read them, you have to interpret what operation you're doing with the scientific notation, then do that operation. Okay, I hope that helps. I hope that you're able to complete this Delta Math really well, and thank you for showing up for your math learning. I salute you. Bye for now, everybody.